My screen is visible, Anand?
Yeah, it is.
Hello, good evening, everyone.
Good evening, Lalit.
Hi, I had a hardware failure at my end, so I had to switch on my
Okay.
laptop again. Okay, so I will share my
Hey
screen.
guys, good evening everyone.
Hi,
Good
Puneet, how are
evening.
you?
I'm good. I'm looking forward to your session.
Yeah, thank you so
And
much.
looking and
Uh,
looking forward to meet our friends here, Anand, Bhavya, and everyone else.
yeah,
Yeah.
yeah. Okay,
Hi,
good evening,
Puneet.
everyone. I hope my screen is visible.
Yes, it is.
Yeah, okay. So basically, the focus for today's session will be CNN only, and especially for back propagation of CNN. And once we finish it, and as we keep on going, we will be covering basics also of the CNN. So I have jotted down certain things before we start for the back propagation. So CNN mainly, what is the objective? So typically CNN is used for image classification. So your last objective function, whatever it will be there. So generally it is a classification. However, in the quiz papers you might have seen in the last, there are various kind of activation functions have been given. ReLU has been given. In some averaging has been given. So objective function derivative of loss or the loss gradient at the output layer. Now, what is the process in a convolution layer? So generally we know that in CNN we have got a convolution layer where we are applying some filters, and on after that output we might apply some activation function of on that layer. For example, ReLU we can apply, or we might apply the max pooling with certain stride, and finally we flatten it and to get a flattened layer, and then we have got a fully connected layer which is has got some activation function with output layer, and we get some output. So I will draw this diagram also. So with this basic architecture of CNN, what do? We make a forward pass. And what do we do in the filter? In the filter we randomly choose some values. We are giving an input of image, and we in the kernel we are having some random values of weights in that kernel, and then we get a y hat. Now, how we train this CNN? Now, depending on the loss function, now there will be a difference between actual y and the y hat or the y prad. Now we do the back propagation to update these weights of the kernel. So that is the similarly same action what we did in the artificial neural network. Here only the types of layers have changed in the CNN. So as we go, we will see how it is done. So there, here I have made the same diagram over the back propagation, that we are taking the loss from the output layer to here. So here I will draw, and I request everyone, if you have any doubt, you can interject at any point of time. So here I will draw a basic CNN, and we will see here only I will cover the certain basics of back propagation. So if we have some image, or this is the input, I will say 1 1 0 1 0 1 0 0 1, and let's say 0 1 0 1. On this we apply a filter of, so we will get an output here. Let's call it A1. Here we apply, for example, a ReLU function on this. ReLU, we know that if the number is greater than 0, then it will take, otherwise value will be 0. From here we take a max pool. So max pool, what it does, for example, deliberately I have selected so that only one number comes here, and this we feed to, for example, a sigmoid to get y hat. So here typically all the questions in the quizzes or a basic CNN structure will be like this. So for example, if we select a filter, initial filter, if we select, for example, 1 0 and 0 1. So at A1, the output of this we will get, for example, in this case we will get 2, here we will get 1, here we will get 0, here will come 0, here we come again, this is 1, here we get 1, here we get 2, here we get 0, and here we get 1. So when we apply ReLU here, so it will not make any difference. It will come 2 1 0 0 1 1 2 0 1. We apply a 3 into 3 filter of max pool, so we get a value 2k. On this we apply a sigmoid of 2. Can anyone give me a value of sigmoid of 2, please? If I'm not wrong, it should be around 0.95 or something. Now we know in the back propagation that we have to update these values. Like I covered, that these are the random values we kept. There is an actual y and this is a y hat. So in this case, for example, if we take actual y is 1, example, then our objective is to update f. We know update rule for f is f minus eta into del loss over del f. So we have to find this. For this example, we just take, for example, eta is equal to 1. Now del L by del F, again we use the chain rule to come here. It will become del L by del y hat, del y hat. For example, there was an A4 here, del A4 by del A3, del A3 by del A2, del A2 by del A1, and del A1 over del F. Now, loss function, we know that for a sigmoid, so we take loss function is equal to MSE, equal to half y prat minus y square. So this value we know, this becomes y hat minus y. Y hat is equal to sigmoid of this. So derivative of a sigmoid, we know it becomes y hat into 1 minus y hat. So this is the loss which we are getting the output layer here. This is, and how the loss is flowing. Now, this is a different thing from a normal artificial network, which I will cover now. So please pay attention here. Till here, there is no difference between artificial neural network and CNN. We have followed the same. So if there is a weight here, we will update this weight with respect to this loss. Now, when we come to this max layer, this entire loss which has come till now here, this loss will flow through here. But if we see the neurons here, only the neurons with value 2, they have participated. Okay, so these neurons which value is less than 2, they have not participated. So any change in these values will not make any difference to our this program or to the loss. So what do we do? What does it mean? It means that all the neurons which have not participated, we make their values 0. And the neurons which have participated, we keep their values as 1. This is an important part. Is this clear to everyone? This is the only difference between the CNN and the artificial neural network. Anand, is it clear?
Yeah. So
Am I
so
audible?
one question I had was the max. This what you have written as max is the max pooling, correct? Is it the
Yes,
max
yes.
pooling? Okay. So what is the
Yeah, this is a maximum pooling with a size by which I'm just taking an example. We have selected some size by which we are getting 2, for example.
okay? So this is you have used a 3x3 filter on this. Is that
Yes.
what? Okay.
Yeah. Yes. This is just an example to cover that how the loss flows back and which are the neurons which are not participating. Because in CNN, all the neurons, they don't participate. So those neurons which are not participating, we make their values as 0.
Okay.
Okay.
Yes.
Okay.
Yeah.
Now we take this loss. So we have reached A2. Now from A2, we have applied ReLU. So remember the derivative of ReLU is either 1 or 0. It is 1 in case where the number is greater than equal to greater than 0, and it is 0 otherwise. So here we got 1 0 0 0 0 0 1 0 0. So here we don't have all positive numbers. In case, for example, there was some negative number here, for example, that would have also become 0. Okay. So at A1, finally the loss which we have come here. So this loss up to del A2 by this portion, this loss will come from the calculation. This part will become 1 0 0 0 0 0 1 0 0. So just an example that our y prad was 0.95. So this will become
Lilith, can you just explain that 100? How did you get it?
yeah. So I'll cover again. Okay. Oh shit. Okay. So see this here was the maximum layer 2.
Right.
So only the neurons whose value is 2, they are participating.
Correct.
Okay.
Yeah.
So all other neurons which value is not 2, they are not participating. So the loss will not fly through those neurons.
Correct.
So those neurons values I have made 0. And only the neurons which are participating, I have kept their value as 1.
Okay, that layer I understood, but I'm talking about okay. It's not that layer. I'm talking about the previous layer.
Yeah, same here, the ReLU layer. Yes.
Okay. So ReLU layer, see all of them, these are the positive numbers. So this 1 which is there, its derivative will be 1. Okay. Or okay, just hold on, just hold on. I think I jumped, I took a shortcut. So just to explain, we come to this max layer. What I said, so first I go do this again. This 210 is okay. This is 0. This is 1. This is also 1. This is 2. This is 0, and this is 1. So from here, when we applied ReLU, we got again the same 210 0 1 1 2 0 1. So we came here. This is the max. Here we have formed till now. We formed del L by del A4. We had come here. This is the y hat minus y into y hat. 1 minus y hat is the this value del at A4. Del A4 by del A3 becomes this value. So your loss is flowing from this value, which is 2. Now when we come to this layer, I will use a different color. So only the neurons whose value is 2, they will be participating. Rest, all of the neurons, I will make values 0. Is this clear?
Yes.
Okay. Now when I go to ReLU, derivative of ReLU is 1 when the number is greater than 0. So here I will get 1. For this 2, I will get 1. For rest all, it is 0. This is how I got this value. Is this clear now?
Yeah. Okay.
Okay. So remember in this, in the back propagation in CNN, important part is
Hello.
loss.
Sorry to interrupt.
Loss at output layer. Yes, please.
Sorry to interrupt. I was just
Hello.
clarifying. Yes. Hello. Hello.
Yes, we can hear you. Yes, you are audible.
I was
Hello,
just
Anand,
clarifying.
any problem in my audio?
No, we can hear her.
Yes, please tell.
Yeah. So the last layer, that is A1 layer. So for the ones we are getting derivative 1, and for the rest we are getting derivative as 0. Is that all?
Yes. It is not about the derivative. It is you can say that those neurons, they are not participating and they don't affect our loss. So those values are zeros.
Oh, okay.
Okay. So now if you see this architecture, we had made this long chain rule, but finally it has collapsed into what? It has collapsed into del L by del F is equal to del L by del y hat and del y hat over del A1, which is the first convolution layer here. So here you have to make that flow, that how the loss is flowing, which all neurons are participating to derive at this A1. And now another important part, and here will be del A1 over del F, which is nothing, this is input. Because your A1 is equal to input convolution by filter, and we are taking derivative with respect to filter, so we get input here. Now this value which is there, now we just will take an example of the same values. For example, we got y per at 0.95, actual y was 1, then derivative of sigmoid, which is y hat into 1 minus y hat, and here we had got which all neurons were participating. So we got the value 1, 0, 0, 0, 0, 0, and 1, 0, 0. And this is input, for example. So here we will get some value. Just take an example. It is some 0.05, just example. Okay, I have not calculated. So this finally full will become 0.05000000.0500 and input. Now this is nothing but input convolution by this matrix 0.0500. And when you do the convolution of the input by this del L by del A1, you get del L by del F. And by this, now you can update your F minus eta into del L by del F. Is this clear? Okay, the concept only. We will be solving some questions from the PYPs, but I hope concept is clear. Any doubt, I can repeat again. There is no problem. Anyone?
Lilith, so the 0.05 that you have written in the last step, you said it's an example.
Yeah. It's just an example. I'm not.
Is it for the first part, the 0.95 minus 1 into 0.95 into 1 minus 1? Is it
this part.
For that part? Okay.
Yeah.
Okay. And
yes, sir.
Okay. So the matrix you have.
Yes.
Minus 0.002.
How much, Bhavya?
Minus 0.002.
Just hold on. You're not audible. Is this a minus 0.002?
Yes, sir.
Okay, so all this will become this. Now, you carry out a convolution of the input by this. So when you will do the convolution of this, the size which you will get, it will be of the same size of your filter size. And you can check that. It was 4 into 4. This is 3 into 2. So your first convolution will be by this. You will get one value from here. You will get one value from here. You will get one value from here. And you will get another value from here. So you will get a size of 2 by 2, which is the filter size. Okay. And then you update by F using this eta. Shall I repeat the steps again for the benefit of all?
Yeah, I mean, did you say 2 by 2 or
yeah,
is it 3 by 3? Hello?
See, filter size is 2 by 2. So your del L by del F. Hello, Anand.
Yeah.
Hello.
I can hear you, Lalit.
Yeah, I can also hear you. So
there is some lag, I think, at your end. I guess.
What I was saying, F size is 2 by 2. So your del L by del F is also to be 2 by 2. Okay. Give me 30 seconds. I will change my connection. 30 seconds, please.
Hey, Anand, you also got 3 by 3, right? So far, the matrix.
Yeah, yeah. The matrix that he has written is 3 by 3, and
Right. From right to left, it's coming 3 by 3. And then the filter should be 2 by 2. Did he explain how it came to
no,
2
no,
by
no.
2?
I think he will. I think he will come back and explain.
All right, fair enough. I think Bhavya knows the answer.
I have a couple of assumptions, but I would prefer to have them confirmed.
No, it's good. How he's explaining, at least it's good. I'm being able to follow it.
Hello, Anand. Am I audible now?
Yes, you are. Yeah.
Okay. Okay. So what I was saying that your filter size is 2 by 2. So to update the filter, you use del L by del F. The size of del L by del F has also to be 2 by 2.
The matrix that you have written is currently 3 by 3, correct?
See here del L by del A, I got 3 by 3. But when I do the convolution of this
Oh, I
on
see.
the input,
Okay.
I will
Okay.
get 2 by 2. So
Can you repeat that step, the convolution step, the final
Yeah.
one, to bring it to 2 by 2?
So for the benefit of all, should I do again just for the benefit of all? This is the input, and now I will not use this. I use the convolution. I get A1, for example. I apply ReLU here. I get some values. On this, I apply max filter. I got some values. And now I will be using a different example. Then I do flatten this maximum values which I've got. This I connect to, I sum them and use sigmoid on that to get y hat. And I will be using a simple example 1 1 1 1 1 1 1 1 1. Filter I will apply 1 0 0 1. So here I will get 2, here I will get 2, and let's make some minus also. -1. And let's do this -1 just to make it more interesting. So this will become 0. Here it will become 0. This will become -1 plus 1. So this is given 0. Okay, we will solve certain questions, but just to cover that, what Puneet has asked, we do a forward pass. We calculate all these values which are there. We calculate A1, we calculate A2, we calculate A3. This is a flattened layer. A4, we calculate A5. On this, we use a sigmoid. So this is sum, this is A6, and we get y hat. For the back propagation, we have to find del L by del F. So the important parts are in this is first of all the loss at the output layer, which is del L by del y hat or del y hat at del A6. And from here, this loss which flies back, here you put whatever the values you have got and see which neurons are participating to get del L or del A6 by del A1. Finally, we get del A1 over del F. So this part is the one which I had covered, saying that for that particular example, it was y1 minus y hat 1 minus y hat, which was at the output layer. And then we got the here the neurons which are participating. Just an example, 001, 101 for that particular example. And here we get input. So Puneet, what do we do? This first part which is there, here we will get some value. For example, we will get 0.05, 0, 0.05, 00, something, 0.02, 0.010, and this is the input. So what do we do? This input which is there, on this input, we do the convolution by this. And that is, that, yes, on this input which is there, now we do the convolution. So we apply this. So in that case, it was 4 into 4. We applied 3, 3, 3, 3, and we got the output 2 by 2, which was matching with our filter size. That is the part.
Okay.
Yeah. So with this concept, let's take a very, very simple example from your PYPs. And I will encourage everyone just to use the concept and try to solve this question. It is a very easy question. So this is the question. Is it visible to everyone?
Oh, this is in the back propagation, that handout also, Bhavya, the one you shared yesterday.
Okay. Okay. Yeah. So there is an input array of 1 dimension. And we have got true label y is also given 1. Kernel is given. So we have to first do the convolution. Can everybody try with me just the concept wise so that we are clear about this?
Yeah, sure.
Yeah. So what will be the answer of this? Bhavya, can you give me the answer of this?
Should be 1, -1, 1, -1 in that series.
Yeah. So first this, then this, then this, then this,
Right.
then this, then this.
Yeah, so 1 into 1 plus 0, then 0 minus 1. Yeah, got it.
Okay. 1 0 1 0
1,
1 0
it will be -1, right?
Yes, 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 yes. Sorry. 1 minus 1 1 minus 1 1 2 3 4 5 6 minus 1 and 1.
Right.
Okay. Now the question says pass through the ReLU activation. So this, let's say this is A and H is equal to ReLU of A. So once we pass through ReLU, we know that all the negative values, they become 0. So this will become 1 0 1 0 1 0 1. Now compute the output y hat by averaging the h and calculate the squared error loss. So y hat is average of this. So average of this will become 4. This becomes 0.37. So just to visualize the concept just now which we discussed, this is the input which has been given to us. We have applied a filter. We got some output here. On that we applied ReLU. After ReLU, your output function is averaging. We did the averaging to get the y hat. Now, if we have to update now the filter, how should we do that? We will apply the same fundamental which we learned just now, that del L by del F. First, we have to find at the output layer. So this is my output layer where I'm doing the averaging. So this is A1, this is A2. So this will become del L by del y hat, del y hat by del A2. This is my output layer. And from here, now I find for the del A2 by del A1 and del A1 over del F. So in the question, the loss has been given the MSE, so straight away this will become y hat minus y. Now see here for the averaging function, if y hat is equal to average of A2, then del y hat by del A2 will become, there were how many numbers? There were 7 numbers. So this will become 1 by 7. Okay. Del A2 by del A1, it is a ReLU. So whatever the values which had come, we had got 1 0 1 0 1 0 1. So straight away it will pass the same. And now from here we can see that these are the neurons which have not participated. Okay, so at this part which is there, del A2 by del A1, this will become 1 0 1 0 1 0 1, because these values minus ones which were there, they have not participated, and this becomes input. So y hat minus y, it will become how much? This sorry, I have done the wrong calculation. This will be 0.7535 77. So y hat minus y will become 0.57 minus 1, 1 by 7, 1 0 1 0 1 0 1, and here we had input. So if you solve this, this will become minus 0.43 divided by 7. So this will become minus 0.06, 0, minus 0.06, 0, minus 0.06, 0, minus 0.06. And like I covered earlier, to do the convolution on the input. Our input was what? 1 0 1 0 1 0 1 0. So we will get two values, one this and second this. So here when you do this convolution, first one, so this will come 1 2 3 4 4 times 0.06. So this will come minus 0.24, and when you do here, it will get multiplied by 0. So this will become 0. And they have asked the sum of the gradients. So sum of the gradients will become minus 0.24. Is this clear to everyone? Hello, Puneet, am I audible?
Yes,
Yeah,
yes,
yeah,
yes.
How did we get that 1 by 7?
Okay.
Yeah,
The value
like the same
basically.
question here.
Okay. So this 1 by 7 which has come, it has come from your activation function of the output layer. In the output layer, what we have done here, we have done the averaging of 7 numbers. These 7 numbers which are there.
Right.
Okay. So the loss which has come, when you pass through an averaging function, you divide by the number of that. Okay. And remember, okay, there is a catch into this. When it is only for the output layer, if this is somewhere here that you see, you say I'm doing the summation here, then the loss will fly through this. It will not get divided. It is only at the output layer activation function. That's why I covered that this is very important to calculate the loss at the output layer. Okay.
Not clear on that. So if let's say if average was somewhere in the second layer.
In the second layer, if we are doing, let's see one architecture of one CNN. If we say that this is an input, you pass through filter, you get one layer, you sum them, for example, here, and you get this layer.
Okay.
And on when you sum them, you will get a scalar, and on that, for example, you apply a sigmoid to get the biped. Okay. So
Right.
what I wanted to cover that here, this is your loss at the output layer. For example, if this is A1, A2, A3, and when you pass this loss now in this layer, here you will not divide. Here it will pass through everything. Okay, that was the point I was trying to make.
Yeah, that's because it is a sigma, right?
Is it clear?
It's a summation.
Yeah.
Okay, but if it was an average,
It is a summation or.
Oh.
So here we don't do the average in the convolution layer. It is only we are doing the at here.
Okay, but if you are doing the averaging in any other layer, that also would be 1/7, right? I mean, that will be 1/n.
Yes, yes. In the average,
Okay.
But averaging generally we don't do in the inner layers.
Okay, okay, understood.
Okay. So this was the simple most example just to cover that concept that how we are taking a loss. So we are calculating at the output layer, and thereafter we are taking that loss to the first convolution layer, and how we are making those layers 001 and 100. So that was one example. Now we will take some more detailed example from your PYP only. This again, I will encourage everyone to please solve along with me. So consider an input matrix X of shape 4 into 4, kernel filter of shape 3 into 3, and there is a bias in this is equal to 1. Assume stride is equal to 0 and there is no padding. Compute the convolution sum by sliding the kernel over the input block. Enter the sum of elements in A. So this we can do. So A will become, first we slide over this. So this will become minus 1, minus 1, plus 1.
This is -1, I think.
And there is a bias.
Okay. So
Okay,
that becomes
so this
0.
will become 0.
Yeah.
Yeah. This -1, -2, -3, -3 plus 1, -2, -2 plus 2, 0, 0 plus 1, 1. We come to here, this is -1, -1, -1, -2, plus 1, -1, -1, -2, -3. This becomes 0.
-2. -2.
Plus 1, -2.
-2.
Last
Yeah.
one.
Last one is
this is 0.
this is -1.
This is -1,
This
2 plus 1, 1, 1 plus 1.
2.
Is this
Yeah.
okay?
Yes.
2, no? Okay. So somebody can open, I think this is from the previous term question paper. If somebody wants to check. Shall I open that? Or somebody has got?
Which paper is that? Yeah.
This is the last term, January 24.
Okay. Okay.
Yeah. these questions are very, very important because, you know, every next question is dependent on this. So our answer is correct here. The sum is 1. So if we see the sum of A is equal to 1. Okay. Now,
so when we compute the bias, so when bias would be given, so after the convolution, we will simply add the bias.
yes. So your A is nothing. Your A is equal to X convolution by F plus bias. Okay.
Okay.
Now this feature map A is then passed through a max pooling layer with a kernel size 2 into 2. The result is then passed as an input to the sigma logistic function. What is the output value y? So when you pass it to sigma max, you will get what? You will get 2, and y is equal to sigma of 2. Sigma of 2 is what? How much? Sigma of 2 is
0.95, I think.
plus
Oh,
0.88.
0.88. Okay.
Yeah. So
I
this
think what
is
we
your-
did in the previous example was wrong then.
Yeah, it was just for an illustration.
Yeah,
It was
I know. Yeah.
to clarify the concept. Okay.
Yeah.
So here we get this. Now we have to suppose the gradient of the loss with respect to y is -1. They have given already, so we don't have to use. What will be the value of del L by del W00, where W00 is the element of kernel at 0, 0 position. So see, our kernel is what? This is our kernel. Okay.
Yeah.
So what is the question asking? Question is asking WL by WF, which will be of the same size, and it is asking W00 means this value. There will be 9 values, so it is asking this. So now applying the concept which just now we learned, we will try to obtain the full and to update the kernel also. So what has happened in the question till now? There's an input. We have applied a filter. We got some value. On this, we applied a max layer. We got some value. On that, we applied a sigma to get y. So like I covered, now there are 3 parts of this. This is A1, A2, A3. So to find del L by del F, I have to find del L by del A3. Then I have to find del A3 up to del A1 and del A1 over del F.
Yeah.
So del L by del A3 is nothing but del L by del Y into del Y over del A3.
Y hat.
Okay, in this question they are using Y terminology. That's why I am using Y.
Okay.
Del L by del Y, they have given to us how much? -1. Okay. Now, del Y by del A3, Y is equal to sigmoid of A3. So derivative of a sigmoid will become Y into 1 minus Y. Is this clear?
Yes.
Okay. Very nice. And now you see, here we got the max value 2. Now, when we come here, it means all the neurons which are not 2, they will not be participating. So what do? We make them 0, 0, 0, and only 2 part which is there, it will remain. This will remain as 1. And this part will become infinite. So can you calculate this minus 0.88 into 1 minus 0.88? Anyone? Bhavya, can you give me this figure?
0.88 into 1 minus 0.12.
0.10.
0.10. Okay, very nice. And what do we do? Now we do the convolution of input. So this entire term will become 0, 0, 0, and this is plus or minus hai kya Bhavya?
Sir, minus.
Minus 0.10, yes. So now you see, when you do the convolution, you see this, in the question they have asked only this one, but we will calculate full. So this will become 0, this will become minus 0.10, this will become 0, here again minus 0.10, minus 0.20, 0, here 0, here 0, and here minus 0.10. So this is our del L over del F. And in the question they have asked at 0, 0 position, so answer is this. And your F will become F minus eta into del L by del F. That's how you will calculate. In some question they might ask you this also. Okay. Another very, very important concept, please listen carefully. Like we reached a state where we said that del L by del F is nothing but convolution of input by del L by del A1. We had come here, we made this statement, and we have been using. Similarly, for the bias, del L by del B is equal to summation of del L by del A1. This please remember. Because in some questions you will have to update the bias also. Like in this question, if you're asked that update bias, so bias will be bias, the value of bias is how much? Is 1 minus eta, for example, take eta is equal to 1, and summation of del L by del A1. So del L by del A1 is this part. And summation will be, how much it will be? Minus 0.10. So your new bias will be 1 plus 0.10 is equal to 1.1. This is how in a CNN your parameters are updated. And you can see any CNN, the block which we have made, contains the same blocks. It will have convolution layer, it will have some max layer, then ReLU, then output has come, then again one convolution layer, some max layer, some activation function. So you keep on going and finally there is some output. So you keep on going step by step to update these parameters. There will be one parameter here, there will be parameter in this convolution layer, in this convolution layer, in this convolution layer, and that's how we keep on updating these stepwise. And this is how a CNN is trained. Now, with this, gentlemen and ladies, I have finished. Okay, if there is any question, any doubt, you can ask me anyway.
Yeah.
Bhavya, any question in your mind, or Anand?
I'm just trying to summarize what you said. I'm just so the max layer. So let's say the layers are of different kinds, right? We have a max layer, we have a sum layer, and we could have a ReLU layer or an average, right? So these are the. So in each of these, can we say that? Can we say that, for example, for the max layer, can we say that the DL, when we take the derivative, it will always be the 1 for the maximum and 0 for the rest of it?
Yes, for the max.
Will it always hold good, or will it always be true? Yeah. Okay.
If it is a max layer, so I will cover again. These are the three parts of the CNN. One is an output layer. This is an output layer. Now, in output layer, you will have some activation functions. Okay, it can be software softmax, it can be sigmoid. Generally, we don't do averaging, only in PYPs just to check the concept, the averaging has been used. So these are the ones, sigmoid okay, we use for the continuous function, softmax for classification, and averaging just an example. So we are interested in three parts in this CNN. First part is this. I have to know what is the loss here at this last here at this output layer. For example, if I say this is A4, A3, A2, A1, and this is input. So depending on the activation function, you will have some del L by del A4 here. Is this clear, Anand? Now here.
Yes.
Typically in the CNNs, your last layer which is there, generally it is a flattened layer. What do you do? Whatever layers you have got, for example, here your output was something 1, 2, 2, 1. What do? You flatten it 1, 2, 2, 1. So generally it is a flattened layer. This loss which is coming, if I denote by green, this loss which is flowing, it will flow from all the parts unless they are 0. If it is 0, then it will not flow. Now from here, you can see that this one, from where it has come from here. So this loss will flow from here, this loss will flow from here, this will flow from here, this will flow from here. Now, here you come, you see which are the neurons which are flow positive for this. So you have to check from where the loss is flowing back. Anywhere due to some activation function like ReLU, here there was some negative value, it became 0. So loss will not flow from here. In case it is a max, then it will flow only from that max number. Then it will discard all the numbers. So then it will become like this. It will flow from this number. So depending on the problem or on the question, you have to find out that how the loss is flowing back. Because your main objective after calculating this is to find this one. This is the most important part. So first you find del L by del A4, which is the output layer. Then you find del A4 by del A1, which is your convolution layer. And then del A1 over del F is nothing but your input. Once you have calculated this part, then you have to do input convolution by this part. For example, let's call P to get del L by del F. That is the basics. Shall we attempt to take one more question, maybe much more detailed question to understand?
So if Lilith, if there are two convolution layers, both of them will have the same format, right? So there will be that convolution symbol that you have written for 2 times.
Yes. So I will I have got one question from PYP where there are 2 convolutions. Okay, so we will see that question also.
Okay, great.
Yeah. So I have taken, yes, this is a question. So this is a question, input matrix X. There are 2 kernels. One is K, another is F. Are given below. The bias value for both kernels is initialized at 0.5. So there is a bias also. This is K, this is F, this is X. Assume no padding and stride 1 wherever necessary. So first is create 2 feature maps by convolving the kernel KF over the input matrix X and stack the outputs to create a tensor. The dimension of A is m into n into 2. The first feature map is of size m into n is the output of K. The second is for F. What is the sum of the elements in the tensor A? Okay. So let me take this to a fresh page. Okay.
By the way, Lalit, will you be able to share this not this document with us?
It is in rough state, but definitely I'll share.
Okay.
I'll convert
Yeah.
it to PDF and then I'll share.
Great.
Okay. So I go to a new page and we go step by step to understand everything. So they have given us one input, and in this case, calculations that when we apply two filters and there is a bias also. So what we will get two outputs, and outputs will be looking like this. They will be like this outputs, one output here, one output here. If you see mathematically, they look like this. So it will be a tensor. So let's find it. So bias in the question is also given. Bias is how much? 0.5. So let's calculate. Go step by step. So this will become 0, 1, 0, 1. So only these are participating, minus 1, 1, 0. This will become 0.5. We come here only 2. This will become 2.5. Here only 1 is participating, 1.5. Here both are participating, 2.5. We come here only 1 minus 1, 0, 0 plus 0, 0.5. We come here, both are participating, 2.5. Here we come, 1 is participating, 1.5. Here we come, 1, 1 minus 1. So this becomes 0. So this becomes 0.5. So our A in the question, what they have asked, the tensor is like this. So if I draw here, or I can write here that I have got two outputs, 0.5, 2.5, 1.5, 2.5. Another output I got 0.5, 2.5, 1.5, and 0.5. So A we have got, this I'll drop off. So this is A. They have asked sum of A. So sum of A is 2.55, 7, 7, this is 4, 11, and this is 12. 5, 7, 12. Okay, so this part is there. Some. Just having made some mistake. In the summation, I think we have made mistake. 2.5, 7, 3. Bhavya, can you help me? Can you check this convolution?
Sure, sir.
This.
Here, these two have participated 0, 0.5, correct? Here, 2.5. Here, only 1 has participated. So here, 1.5. Here, both have participated again. This was 1.3. Here, 1.5. This was wrong. This is 1.5.
I think the answer is 12, right? What you got is right, I think.
I'm just checking. 1 plus 1, 1.5. This is 0.5. Here we come, we both are participating 2.5. Only one is participating 1.5. Participating 0, and this becomes 0.5. So sum of A is 3, 4.5, 2.57 plus 3, 4.55 is equal to 12. Okay. Okay, now let's go. Okay. Now flatten the tensor A into an array C by following the row measure ordering, and they have given us that how it is done. So the next output we are doing flattening here, next operation. So now we get C, and C will look like something like this: 0.5, 2.5, 1.5, 2.5, 0.5, 2.5, 1.5, and 0.5. So this is our C. We have complete. Then they are saying do the max pooling with the kernel size of 2 and try to store the result in D. So what do? You do the max pooling here, and what is the, he's saying size or stride of 2. So this is how. So D will become 2.5, 2.5, 2.5, 1.5. This is the max pooling. And sum and all that we can leave it. Sum the elements in D and pass it through ReLU activation function to get the Y hat. So now D, they are doing the summation, passing through ReLU. So summation 5 plus 4, 9. This is the output layer, and we get Y hat is equal to 9. Is this clear again? Now we have to do the updation of the kernels of both K, F, and bias. So can we follow the same route which we did? So what we will do, we will find del L by del, for example, C, D, let's call it E, let's call it F, del F. This is at the output layer. So we find first for K, del L by del K is equal to del L by del F, and then del F up to the convolution layer here, del K, this A, and del A by del K. Now, can somebody guide me how to go about this question? What will be del L by del F? In this question, I think they have given that sum the elements in D and pass it through the ReLU activation function. Okay. So if there is a loss coming from here, if it passes through ReLU, what will be its value? What is the derivative of ReLU? Anyone?
1, there should be 1, right?
Yeah.
All the
Yeah. So this is 1. And this was the part, okay, Anand, which I was mentioning. See, this summation which is there, it is outside the activation function. So this loss will fly through this. Okay. Now this loss is flying through which elements? Only 2.5, 2.5, 2.5, 1.5. So when we come to layer C, all the neurons which are not participating, they will become 0. So here this will become 0. This becomes 2.5, 0, 2.5, 0, 2.5, and here is 1.5. So this will become 1.5, this becomes 0. Now further, when I take them to K and F, now see which neurons are participating, which are not participating. So this is not participating, this becomes 0. He is participating, he becomes 1. He is not participating, he becomes 0. He is participating, he becomes 1. Here, he is not participating, he is 0. He is participating, he is 1. He is participating, he is 1. He is not participating, he becomes 0. So we have come del L by del F, 1 into 1. And in this question, they have given that del L by del Y is some 1 or minus 1 in the question. And del F by del A, from here, we have found that for K, I have to do convolution of input by this loss, which is flying back, by this 0, 1 and 0, 1 for K. For F, I will have to do input by convolution by 0, 1, 1, 0. Now in these questions, they are giving you del L by del Y hat. However, in some questions, they can give you some activation function that this is sigmoid and your actual Y is, for example, 0.5. So in that case, you will have to calculate this del L by this value which is there at the value at outside A4. So here we can calculate and find these values. So here if I get, for example, 0.01, so this will become 1 by 0.01, 0.01, 0.01, 0.01. And when you do the convolution, you will get this, update these parameters, and then you will get the answer. Now, coming to the part for the bias updation. Now see, they have given bias B for both. So in this case, your bias updation will take place for both. So B for K will become B minus summation of del L by del K, this A K, and B F will become B minus summation of del L by del A F. What does it mean, AKA and AF? This is AK and this is AF. So there are two questions in your PYPs of the same nature. I will request all of you kindly solve these questions. It will give you a lot of confidence and your concepts will become clear. So important concepts which are there and which we have seen is one at the output layer, find the loss derivative. From here, go through all the layers in between, come to the convolution layer and try to see which all neurons are participating, which are not participating. And once you find this, do the convolution of input by this to get the derivative of with respect to your filter. And this will update the filter. And for the bias, what you do, if there is a bias, then you do bias updation by summation of this. Whatever this you have got, you summed it, and then you will get. This is the last, for example, del A. Is this clear, okay? Any doubt in this? Anand?
It's clear. I mean, as you have written it, it all sounds so simple. We have to try it.
Yeah. Yeah, concept is slightly different from the artificial neural network, in which we were continuously going through sigmoid or through ReLU. Here, this max function is there. It does not have any derivative, but it says only that only the which neuron is participating. If I'm taking the neuron which has got the maximum number, then all other neurons which are there, they're ineffective. So I have to make the values for those neurons as 0, and the loss will fly through only this neuron. So these are the concepts. If you use them, you reach the first convolution layer, taking the loss along with that, and then you do the convolution of the input by this, the value which you got, you will get the answer. This is how the back propagation in CNN happens. I'll share again this document with all of you. I'll convert it to PDF and I'll post it on the discourse. And then I will be able to answer.
Nice. So Lalit, are you covering something else today, or we are done for today?
Yeah, this was only for the back propagation. In fact, there was a live session yesterday for the CNN for week 8.
Right.
So
yeah, we were there. Yeah, we were there too. Could you come back to the problem we were solving? I have 2 things to ask you, if you don't mind.
Yeah, please.
So first is that when we started back propagating and we got ReLU, if suppose the value of y hat was 0.
Okay.
Right. So what would happen then? That means it'll all be 0?
No. See.
Then ReLU will be 0, right?
No. Okay. I'll see, you have got some y hat here. For example, in this case, it is 0. Okay.
Right.
Your
negative
actual y has got some other value.
Yes.
If it is 0 and your y hat is 0, then it means your kernel which is there, it is perfect. No need to update.
Agreed.
If it is different, for example, it is 1, and you're using a classification function, then you have used a softmax in the last, and you have got some y hat.
Right.
Y hat is equal to 0, but your actual y is 1, for example.
Right.
Then your loss for the softmax function here, at, for example, if I say it is A4, then del L at del A4, it becomes y hat minus y for a softmax.
Yes.
So this will become 0 minus 1 minus 1.
Okay, right.
And this minus 1 value which is there, now this value will flow through your all the layers which are there, whether it is flattened layer.
So suppose it was ReLU function.
Yeah.
Then the derivative of this for ReLU, anything which is negative will be 0, right? It won't pass through.
No.
Then?
Okay. Here, for example, if it is 1, 0, 1, 0. Okay. And here I use ReLU.
Right.
ReLU means here it was 1 minus 1, 1 minus 1. That's why I got 1, 0, 0. Now this loss which is flowing, loss will flow only from 1 and 1. Okay, still minus 1.
All right. Okay, so when we were saying that for 9 the ReLU should be positive, we should have actually taken in the vector format, right?
Yes. And here, if you see now, when I come to this layer, so only these neurons are participating. This minus 1, they have become 0 now.
Right, but we had a summation function, so it will be a single scalar, right?
Yes, summation function, it is different. For example, shall we take a small example, another one, 1, 0, 1, 0, 1, 0, 0, 0, 1. We apply a filter of, for example, 1, 0, 0, minus 1. We get some output. For example, here in this case, we'll get 0,
0,
0.
Again, 0,
0, 0. This is 1 or 0.
Right.
So we should select some other thing. 1, 1, 0, 1.
Okay. So 2.
And let's make it this.
Okay. All right.
So 1, 1, 1, 1. So here it will get 0.
0.
This will become 1. This will become
minus 1.
Minus 1. This will become 0. Okay.
Yeah.
Now
Right.
this is a good example. And here we do ReLU. So we will get what? 0, 1, 0, 0.
0, 0.
And here we do a flattened. We say we have flattened it.
Okay.
So it will become 0, 1, 0, 0.
Okay.
And this output function which is there, for example, here, that's why I'm specifying that this is the output layer. Here I do summation, for example, to get y hat.
All right.
So y hat will be 0.25, averaging.
Average function, yes.
Okay. And your actual y, for example, is 1. Let's say.
Okay.
Now, and let's say your loss which you are using is MSE. Okay. So del L by del y hat will become y hat minus y. So this will become minus 0.75. Okay. Now, when this loss will come here, I'm interested, first part is the output layer. So when I'm doing the averaging, my total loss is how much? Minus 0.75.
Okay.
But I have done the averaging, so that's why, and there are 4 numbers, it will become minus 0.75 divided by 4.
4.
And this loss, when it will flow, it will not flow from zeros, it will flow only from 1.
Okay. Okay.
Now it will flow from this one. Here when it will come, now these neurons will not matter, they will also become 0.
Okay.
So that's how I got del L by del A1. And here, how much it will become? It will become 1 into minus 0.75 by, so this will become minus 0.75 by 4. And when now to get this, you will do the convolution of 101, 0 minus 10, 0, 01 by this 0 minus 0.75 by 4, 0, 0, and this will give you the del L by del F.
All right. See, okay, this was a good example. Thank you.
Yeah.
Right.
Yeah.
Okay. Thank you so much.
Yeah, anytime. Thank you. Any other doubt, any question in this? So what I will suggest, okay, see the concept, okay, you understand and you apply that concept and go step by step, you will get the answer. You will reach the correct place. And as you keep on practicing, then you know all these things, they will come in your tips that where I have to apply what. And like I covered, if there is a max function inside the before the activation function or before the output layer, then that loss will flow, the entire loss will flow through that. Okay. Any other thing, Anand, Bhavya, Sarthak?
No, sir.
Okay. Any other question?
All good from my side.
Yeah, I have got time here. So, in any question, if you are facing any problem from week 5 to week 8,
week 4, right?
I had a question about this CNN. Just a small thing.
Yeah.
If let's say we do averaging, like you already mentioned that we do averaging only in the last layer, but let's say we do it before, and we do a max pooling after that.
Okay.
So in effect, the effect of averaging would only be limited to a certain neurons that would be part of that max pooling, right? So in that case, the derivative of that averaging would not be 1 by n, right?
Yeah. So I'll give you. I'll take the same example. Just now what we did. So I will copy from here, and we will try it on a different way. So let's say the question was saying that it was 1, 0, 1, 0 minus 1, 0, 0, 0, 1. You applied some filter, 1, 1, 0, 1. You got some number here. For example, you had got 0, 1 minus 1, 0. And here we say that you do averaging. Okay? You're saying this?
Yes, sir.
Sarthak?
Yes, sir.
Okay, so we do, for example, averaging here, and we get, if you do averaging, we'll get 0 here, for example. And now on this, we applied a sigmoid as an output layer. Okay, so now sigmoid of 0 is what? 1 plus 1 divided by 1 plus e to power minus 0 is 1 by 2. 0.5 we will get. Actual y, for example, is 1. So, like I covered earlier, if we are doing averaging in between, it doesn't, here we will not do that divide by that. The entire loss will fly. So here the loss will be y hat minus y, for example, if it is a sigmoid, y hat 1 minus y hat. So this is the loss which is there at the output. Now this loss is flying, and actually this has become 0 value. So this loss will not flow back now. This loss will stop it here only. In case, for example, the value was 2 here and this had become 1.5, then this loss will flow back from the neurons which have participated in averaging. So it will fly through 1, it will fly through 2. So here this part will become 0, 1, 2, 0, because these zeros, they have not participated. Is this clear, Kesarthak? This will become 1.
Yes, sir. Yes, I got it.
Yeah, yeah. I hope, okay, this was the doubt?
Yes, sir. That was.
Yeah. Okay, any other thing? In CNN, number of parameters, how we calculate biases, parameters.
Yeah, I think I had one question from the PYP on the parameter calculations. Hello, can you hear me?
Yeah.
Am I audible?
Yes, Anand.
Okay. So I think this is from the September 23,
yes.
September 23 paper. So if you have, you can share it. Otherwise, can I share my screen?
No. Yeah, I have got.
Okay. September 23. It's the question number 58 is.
Okay.
58 to 63.
No, 58 to 63. Do you have the page number for this?
Not really. I mean, can you search for deep learning?
Yeah, I've done.
Yeah. You are just at that. Yeah, this one.
Question number 58.
Yeah. So just a little bit down. Yeah, this one. Correct. Yeah.
Okay. Yeah. Okay. So we'll copy from here. This is a convolution layer. Very nice. Okay. So we copy the question also. The dimension of C1. So should we go question by question?
Yeah.
Yes. Okay, so first we have to understand the layers. So kernel of size 2 into 2 is applied with a stride 2, no zero padding is used for all pooling layers in the network. Okay. Dimension of C1 is 101. So this is 101. This is 100. This is 101. This is 2 into 2. And for this part, this will become 100. We use 25 such filters as P1 he has given.
Yeah.
Of shape 3 into 3. So there is a confusion here. Here he is saying that kernel is 2 into 2 is used for all pooling layer. Pooling layer means the max pooling wala. Okay, so
right.
My bad. So here, this is in the first one he has given. This is 25. Size is 3 into 3. 3 into 3. This will become 100. And to generate. Any biases there in this question? Any bias? No.
I don't think so.
No bias. Okay. So what he's saying, enter the number of parameters excluding bias, very nice, in the convolution layer 2. Convolution layer 2.
Yeah. So why did you change from 2 cross 2 to 3 cross 3?
Because he has said that this is for the pooling layer. 2 by 2, it is for the pooling layer.
Yeah. So this is the pooling layer that you are writing it, right?
No, here he is saying this is the convolution layer. Here he is specifically saying we are using 25 kernels of shape 3 into 3 with stride 1, no zero padding to generate C2. So from C1 to C2, he's saying we are using this 3 by 3, 25 filters, depth will become 100. Okay.
No, but isn't that confusing? I found that.
Yeah, you're right. You're right. Yeah, you're right. But generally, this pooling which is there, it is generally used, okay, for the max pool. For the convolution, we don't use the term pooling.
No, when it said P1 and P2, I thought it was pooling layer.
PI, yeah, you're right. Okay. Some confusion is there. So we can calculate parameters easily. Parameter will become 3 into 3 into 100 into 25 and plus bias. Bias would have been 25, but there is no bias. So this will become 900 into 25. 225. So this is the parameters here.
Yeah.
Okay.
Okay.
So now we go to the next question. Next question, he says, okay. So here you're right. Okay. What is the confusion? No. So we have reached here C2. Now C2 size, okay, we had to calculate. So C2 size will be output size is equal to input size 101 minus filter 3. There is no padding plus 1. 101 minus 398. This will become 99. So this is 99 by 99 and this is 25. This is C2. Now what he is saying in the next question, to generate the convolution, we know that shape of the flattened layer is n by 1. So again, you're right, because some confusion is there. So now what he's doing, he is flattening this to this.
Yeah.
To this. And this P2, now here this P2 is coming, this 2 by 2 with a stride of 2. Okay. Here he is doing that pooling 1.
Okay.
So for pooling, there are no parameters. Number of parameters will become 0. But we have to check the size. So size will become 99 minus 2 with the stride 2 plus 1. 0 padding. So this becomes 97 by 2 plus 1. This becomes 48.5 plus 1. So this will become 48.5 is correct. 49.5. And then you increase it to 50. So when you do, so you will get something like 50 into 50 and your depth remains 25.
Should you round it up or round it down?
Always up again.
Always up.
Always,
Okay.
yeah. What we could say, ceiling. Okay.
Yeah, when I got this odd number, I was very confused as to what to do.
Yeah, this is always okay. You do the ceiling of this. And now this you change it to the flattened layer. So for the flattened layer, you don't do anything. Just what you do, 15 to 15 to 25.
Okay.
So this will become 2500 into 25. So just try to get this. What is the answer?
625.
100 into 25. But you are right, questions, especially in deep learning, in our term also, there's a lot of confusion. 62,500. No.
Yeah. Yeah, that's what you're getting, but that's
No,
not the.
No. Somewhere I have. Actually, question itself, it is not clear that what they are doing. Question. See, this is clear what they have done. C1 to C2. Now, C1 to C2 they have done. But we know that the shape of the flattened layer is n into 1. What is the value of this? N. So are they doing flattening of C2 directly? If they are doing C2 flattening directly, then it will become 99 into 99 into 25. Okay. This you can post on Discord, Anand.
Okay. Yeah,
Because,
I'll do that. Yes.
Yeah, because the question does not have all the details.
Yeah.
Okay, what is happening in the P2? Okay, they have not said. Okay, they have just given here. And are they flattening by P2 or they? Because generally when you do pooling, you get another layer. So you can
Correct.
post on Discord second. In the meantime, I will also try to find the answer.
Okay. Yeah, sure.
If we do directly from C2, the answer isn't matching. We flatten C2.
If we go from C2 directly, na?
Yeah, that answer isn't matching. So not sure what is happening here.
Okay, if we go from C2 to flattening, then it will become 99 into 99 into 25.
Yeah, so the answer is some 14,000, right?
Yeah, it's 14,000. Yeah.
Yeah, so this also won't work.
Okay, I will check this again, Anand, and I'll post on Discord
Sure.
if I'll get the answer of this again.
Yeah, I will post a question on Discord. Yeah.
Yeah.
I'll do that.
Okay. Chalo, then shall we close again? The CNN back propagation part?
Yes, Lalit. Yeah.
Yeah.
Thank you.
Thanks a lot. Yeah. That helped.
Okay. Thank you very much, and all the very best.
Thank you. What's
In
the
case
plan
of
for
any
next?
doubt, okay, please post on Discourse.
Yeah,
Next,
sure.
Most probably on the weekday, we will have a revision session.
Okay.
And like what we did in the quiz one, okay, we had covered all the weeks. However, in this term, I have taken a revision session for CNN, and I have taken for, I think, if I'm not wrong, for week 6 or week
Right.
5. Week 5, okay, I had covered Adam and all that.
Creation layers, yeah.
Right.
So we will cover especially, yeah, and the previous year question papers. Any doubt, any confusion which is there, so that we'll cover.
Yes.
Brilliant.
Okay, chalo, have a
Can we
nice
do
day.
it?
Thank you very much. Bye bye.
Yeah. Okay. Bye. See you. Thank
Yeah.
you.
Bye. See you.
Yeah. Puneet, tell me.
No, I was just asking if we could do it a little bit earlier, like Thursday.
Yeah, I will try to do on Thursday. That's
All
for
right.
sure.
They'll give us a couple
I'll
of days
request
to study after that. Right.
Yeah.
All right.
Chalo,
All right,
take care.
thank
All
you.
the best.
Thanks. Good
Bye.
night.
Bye. Bye. Good night.
Thank you.
Bye.